Can we start it? Okay. Can you sit? We'd like to start the next session. Next session is technical session 1. Thank you for participant this program. My name is Shishio Tsuchiya, APNIC46 program committee member. I'm basically providing a solution. I'm working at Arista Networks Japan. I'm basically propose my solution and product to the customer, and I also contribute external community. So this time I will do as a moderator of this session. We have three programmers and 4 presenters on this session. The first programmer is Ira. She will explain the approach to the network automation. Network automation is a very hot topic within the network operator, but approach of the network automation is depend on the size of the network topology and depend on the number of equipment. Then let's start presentation. Please welcome Ira.
Thank you. Good afternoon. My name is Ila. I'm based out of Singapore. I'm an engineer with Arista Networks. And I primarily look at software and automation platforms and helping customers as to how they can achieve certain use cases or goals by using programmable and programmability solutions. So a bit about Arista Networks. We're the leaders in cloud-grade data center switches and routers. We've had a phenomenal last 9 to 10 years with really, really good growth. We've up to now 15%, more than 15% market share, and 15 million plus ports shipped. We've been recognized by Gartner and the Forrester Wave as part of the leader quadrant in data center switching, routing, and software-defined data centers as well. I think the crux of the reason behind all of this positioning as in the leader quadrant is mostly because of our hardware strategy by using merchant silicon, as well as our software strategy where we have a single operating system across all our hardware platforms. The reason behind having a single operating system is very simple. Because of the uniformity and the modularity that the operating system allows us, it gives us a unified approach towards programmability and towards automation by leveraging on the modular aspect of the operating system itself. So the case for network automation then, that becomes the foundation for it. When you're able to have a programmable software platform to build on, network automation becomes that much simpler. But network automation, the case for it is quite, the chart speaks for it all. If you see the growth of internet traffic or IP traffic up to 2021, which is not very far away, out of the 278 exabytes globally, more than 108 will be out of Asia Pacific itself, with a regional growth of around 26%. And those are quite mind-boggling numbers if you think of how, as organizations have to scale our infrastructure, our expertise, and our people in a way that we'll be able to handle all of that traffic gracefully. Of course, as you heard in the morning's keynote presentation, the drivers are IoT, mobile adoption. 70% of all IP traffic will be just VOD or video on demand traffic. And so in order to handle all of that, I think we have to scale ourselves, both in terms of skill set as network engineers, but also in terms of the size of the teams that are able to deal with this. But of course, that's not very reasonable is it to kind of scale your team as much as the traffic grows. Also because 80% of today's operating expense is spent on keeping the lights on. So when we think of the future of how this is going to go, NetOps in 2021 it seems to be quite a task, right, with the current approaches that we have, which may be more manual, which may be more box by box, with a lot of network engineers having to do a lot of custom manual work by hand every day. So when we think of network operations, we're also thinking of how the data center is evolving in order to deal with the kind of IP traffic that we are seeing. We want to move away from vertically integrated proprietary stacks, and we want to move towards a more open architecture where you have applications that are not dependent, infrastructure that is not dependent on applications. Also, we want to have best-of-breed ecosystems where we take advantage of the different components of the industry that give us the best performance, not just being locked in by vendors. And of course, we want simple and repeatable and scalable architectures, right? Irrespective of what exact network design that you may adopt, we want the software-defined data center to be programmable, open, modular, and easy to deal with. So in our experience, what we've seen when we work with customers on a day-to-day basis and their approaches and what we recommend to them for network automation, we can kind of divide into three broad categories, right? The first one is, of course, DIY. Typically, these are smaller enterprises with maybe a larger software development team or a software programming team. And because of the scale not being too large, there is the scope of being able to write custom applications or custom platforms in order to maintain and manage the infrastructure. In order to deal with this sort of environment, we typically tend to suggest that the teams use SDKs, that is the software development kits, or APIs in order to write these custom applications and to drive those use cases for their infrastructure. The second use case is for slightly larger environments where you probably have more than 100 network elements that you want to work with. This would be typically using open source tools like Puppet, Chef, which are existing in the market and which allow you to do things like configuration management that have been used by other industries before. Like, for example, software developers probably use these kind of tools for other applications, but we're now trying to use them internally into the network environment. So for this particular use case, we would be suggesting to maybe use the DevOps integrations that we have, which would probably give you a slightly more, less granular approach than the DIY, where you write your scripts and you write your deployments yourself, but more to leveraging the open source tools from a DevOps perspective. The third customer spectrum is when customers they don't really probably have teams that can do the scripting and can manage the DevOps deployments that they have. They just want a tool that works. So in order to deal with a network scale that may be up to 1,000 devices or so, the approach that we take is usually to suggest using a software platform that does provisioning, that does telemetry, that also allows you to do things like software-defined networking, orchestration, and so on. So essentially, these are the three approaches for the network automation that we have seen. But of course, this is not strict. For example, like I've seen large deployments where we use the software platform, but we want to enable custom use cases which can only be done via leveraging the SDK or the API. So it's a very flexible intermingling of all the three options, and it really depends on the use case at hand. So just a deep dive into each of the three approaches and what they really mean. The software development kit approach, which is the DIY approach, is essentially writing native applications for your switch. This is the most granular, the most versatile option because it allows you to have a very low-level integration with the operating system on the switch or router directly. right? It allows you to have, for example, custom control plane. So we had a use case where we programmed a custom multicast control plane for VOD streams. And this was very interesting because of the way they were able to route the streams across based on their requirements. The software development kit for any programmers out there is available in Python, C++, Python being one of the most popular languages out there. C++, although is a very old language compared to Python, but a lot of operating systems are still being written in C++, including ours. So in that sense, the SDK integration gives you that flexibility in terms of programming language itself. Some of the other use cases that I've seen where you want to program static routes into your network, for example, react to ARP entries. So if you see a new ARP entry, you want to take a control aspect based on that. You want to react to port channels or hardware, or monitor hardware capacity in real time. So you want to do capacity planning on the go. These sort of use cases are enabled by using custom SDK applications or API applications that we can write ourselves. The API approach is slightly more different. SDK approaches tend to be on the box. So this is on-box programming. Your script cannot reside on a remote server if you were to write an SDK application, because it needs to have that low-level integration with the operating system itself. The API approach is a little different. You can have your script or your application sitting on a remote server, and you can have that API request talk to the switch and then send a response back. So that's the difference between the two, and API gives you much more flexibility than the traditional screen scraping method that we used to use in the past. Typically, we would use the same JSON protocol, which is the notation, not protocol, forgive me, which allows you to have the request-response communication between your remote switch and, remote server and the switch itself. So it allows you to execute commands remotely and also to get responses from the switch remotely itself. Very, very useful for when you're doing automation and programming for that. Examples for this is I recently helped a customer to write scripts to do provisioning for a two-tier tap aggregation system, where all the provisioning requirements are taken, keyed in by the user really, and then the script automatically pulls up the entire provisioning, the entire running configuration that is needed for the switch, and automatically goes and pushes that configuration onto the switch. So very handy, reduces the number of keystrokes that a network engineer has to put in, reduces the scale of the work that you need to do on a day-to-day basis as well. So these two approaches, the DIY approach, which is the SDK, and the API approach, are very hands-on. It allows you to have that granularity and flexibility that the other two approaches may not have, in order to make that more specific to your use case. Oh, oops, I think my animation has gone away. Essentially, what I wanted to show with this screenshot was to show the JSON request and response that a switch might have with a remote server, and what that translates to when you are looking at it from a code format, right? It's very simple, 4 or 5 lines of code, but you're able to use that, repeat that on a lot of devices instead of having to go into those devices one by one and execute those similar commands. So the second approach is the DevOps approach, which I spoke about being for a slightly larger deployment where you probably have network devices in the scale of hundreds. DevOps is not a tool. It is not a process. I would like to think of it more as a culture. So this culture, it emphasizes the collaboration of software developers and network engineers in order to automate infrastructure itself, right? So most of the tools that you see on the slide, like GitHub, Jenkins, Ansible, Chef, Puppet, these are all tools that have been traditionally used by software developers or programmers. What we're trying to do now is to take those tools as existing and to kind of reuse them into a network environment and try to see how we can leverage these tools in order to operate and make our day-to-day operations that much simpler. So DevOps what I would like to think about DevOps essentially is to think of infrastructure not as its individual boxes, but to think of infrastructure as code. The minute you break away from thinking of your switch or your router as a box, and you start thinking of it as a repeatable piece of code, the faster and the quicker the automation platform seems to get into motion, and the automation thought process seems to get into motion. Because of thinking of it as code, we are able to automate a lot of things that go beyond the day-to-day operation or even provisioning. We can start to automate security and compliance audits. We can start to automate monitoring. So you can see how things go on in your network on a day-to-day level without having to go in and type in a couple of show commands. You can have those reports automatically created, generated, and emailed to you. Right? So it gives you that level of flexibility that going in manually one by one to each box does not. So essentially, you get a little bit of your life back, spend less time doing configurations of VLANs and more time actually architecting and building and designing new use cases that may be useful for you. So when you look at the DevOps approach, there are, of course, a lot of tools that you can consider, but we tend to typically go with Ansible because the community that works with Ansible is very, very large. From an Arista perspective, we have a built-in integration with Ansible, and we use the Ansible playbooks to push configurations onto the switch using SSH or SSL. Of course, all of these tools have free or paid versions of each, and every community is ever growing, but of course, Ansible is the most popular. So the last approach when it comes to network automation is probably more popular because it just is a tool or a platform that works for you, right? There's not too much of scripting, coding, DevOps integration with tools that you need to do by yourself. And typically, it allows you to get to hit the ground running faster. So from a network automation point of view, typically the software that you look at or the platform that you look at from in the market would probably give you either one or two or any combination of these three essential pillars. But what I like to think from our Arista perspective is that our Cloud Vision platform, as it were, provides all the three perspectives. So from the first day when you get your switch, you plug it in, rack it up, power it on. You need your day 0 provisioning, your day 1 provisioning, and your change control management that allows you to do your day-to-day operations. You want to upgrade your software, you want to roll back your network. These are the sort of use cases that you would look for from a provisioning point of view. So when customers ask us for a ready-to-go solution for provisioning, this is typically what we go with rather than building something from scratch. Because we are able to already interact with all our switches and also do the provisioning for it, we are also able to talk to our switches to get telemetry from it, right? So it's, we can have the two-way communication to and from the switch. So from the telemetry perspective, we are able to see the real-time telemetry or the metrics from the switch. We're also able to see a historic perspective of what happened in the network. We're able to see what bugs are hitting us, for example, or what is the forensic troubleshooting that we are able to deal with when we are looking at certain events in the network that may have caused like a large congestion, elephant flow, or packet drops, and so on. So lastly, when we're done with the provisioning and the telemetry, the third pillar is orchestration, of course. When you start to look higher than the network itself, when you want to orchestrate across all the components in the data center, including compute and storage and so on. So if you're looking at OpenStack or OpenFlow integrations or third-party integrations, typically the Cloud Vision platform or a software platform or turnkey software platform could be the answer. So those were the three approaches to network automation. But when we look at network automation as a whole, irrespective of which option we're looking at, it can be a bit difficult because different vendors have different CLIs, different APIs. Different vendors can have even different integrations for the open source tools that are available in the market as well. and also different formats with which we interact with our network elements. So essentially, there is zero consistency in the market today, which is difficult for us as network engineers when we want to consider what is the tool that we want to use and how do we want to use it in order to make our network operations that much simpler. So enter OpenConfig. It's being developed in the industry. It's an industry effort. You can see all the big names that are helping in this initiative. Essentially, it is for interacting with the switch using Yang models, using the OpenConfig platform. And the priorities of what should be developed and what is the roadmap is being driven by operator requirements. So if we were to get integrated into the OpenConfig development stream, we can actually influence the way in which OpenConfig is being worked with so that it works well for our requirements as well. So there are engagements with equipment vendors like ourselves to drive native implementations to support OpenConfig. So going into the future, automation can become simpler if we all work towards utilizing and actually implementing OpenConfig in our environments better. So starting a culture for automation can be starting with baby steps. First, we can start off with ad hoc commands or simple one-liners, like simple show configs or even configuring simple VLANs, right? So that we can see what the trade-offs of using automation for us in our daily operations can look like. Once we start showing value, then we can start thinking of infrastructure as code. Try and get more of the DevOps culture and the perspective of that internally when we start to think of that in that perspective. And then when we have that integration with the development, with the programmability, then automation will be able to create that cultural change in our organizations. But of course, that requires a buy-in from everyone from top down. So network automation, it's a little bit of culture, it's a little bit of the tooling, and it's a little bit of the approach. But of course, these are the three major perspectives that we've been seeing, what I've been working with on a day-to-day basis. With that, I would like to thank you for your time. These are some of the links that you can go to and look at for more information on how we deal with automation on a day-to-day basis. Thank you.
We have a question there. Do you have any question and comment? If you have a question and a comment, then please go to the microphone, front of microphone. Okay? Looks fine. Yes, thank you very much. Okay, next session, next presentation is very interesting IP addresses because within the community, because especially APNIC is interested in this IP address because this IP address range was assigned to the APNIC region, and APNIC confirms the capability of this IP address, but this IP address cannot use in commercial. So APNIC46 assigned this IP address for the researchers. After the several years, Cloudflare starting DNS services using by this IP address. So let's move to the presentation. Please welcome Martin Levy and and
thank you.
Yeah, we have two presenters.
All right. First of all, these are fantastic.
Yes.
But you don't know how good they really are. Because one of the things that it does is it protects us from the lights that are very bright up here. All right. Martin, Olafur, we're both from Cloudflare. We decided to split this presentation because Well, we've both got something to say, and it means you don't get to listen to one person drone on the whole time. I'll introduce it. We have rolled out on April 1st a global DNS resolution platform running on various IP addresses, of which the one that's the easiest to remember is 1.1.1.1. We did this in collaboration, we'll talk about this in a bit, with APNIC and the APNIC labs, and we provide data to them. But we really focus on privacy, and with my colleague Olafur, we'll delve in and talk about that because I think that's one of the big takeaways for this. But we'll also talk about cleanup. We'll talk about the other work that we've done, and ultimately, hopefully, what you'll take away from this is that Cloudflare's goal of building a better internet is really just a very open-ended statement. It's not only building a better product or a better service that we provide, but it's also fixing anything that we can get our hands on internet-wise, and we'll cover that today. To give you the introduction and a subject which is well documented if you read through Jeff Houston's blog that was published in early April, and also on our blog entries when we introduced the resolver. We went into a research agreement with APNIC Labs such that we could run a resolver globally, generate an enormous amount of data, but obfuscate it in a way that the APNIC Labs research folks could use in some useful manner, and actually get this address out there. And we'll talk about just how much it's out there. But this agreement is, as I said, it's worth reading the blog entry and looking at what the ultimate goals of that whole relationship was. The only commercial slide that here is, this is our network, an awful lot of dots. And part of our goal, if I sort of put a different hat on, is that I work on network strategy and building out and adding more dots onto this network, which ultimately benefit everything that we actually do, including this resolver. So, Olafur, you want this microphone? Or that one?
Does this one work?
Yeah.
Yes. Okay, so I'm Olafur Guðmundsson. I work in the engineering part of Cloudflare, and I run DNS services, DDoS, and other stuff like that. So we like to do something differently. We like to fix things we think is broken. We like to do things better. And so when we started thinking about what is it that can make a resolver, public resolver, better than what's out there, when we looked at it. And there were two things that we noticed. First of them was privacy. Almost all of the resolvers out there were not very concerned about the user's privacy at all. DNS is a really old protocol. It has lots of chatting and leaks lots of information, and people have looked at this. But we are at a point in time where there has been a lot of work done over the last 5 years of adding things and modifications to the DNS protocols that allows us to start minimizing the leak. There is all of these things. There are like 7 or 8 new RFCs that we implemented. We were the first ones to provide DNS over HTTPS on a massive scale. We were one of the first to do DNS over TLS and other things. So we built a resolver that was based on an open source software from the Czech registry, not resolver, and we wanted to make it better. And we have been submitting lots of code patches to it. But query minimization is one of the things that is easiest to understand. So I'm going to start with that one. Basically, old-style resolvers, when they go out and do recursion, they send the full query name and hope for and want to get it back. But we know the root is only going to give you one label back, so why ask it? And that is what query minimization is. You send only the minimum you need to get to the next label. So the .com server never finds out what name inside Cloudflare you are asking for, etc. And this also has a few other benefits in that it makes the packet smaller and basically is a great thing, but there's all kinds of crap out there that doesn't like this. There are software that assumes they're going to get everything. There are systems that don't treat empty non-terminals, which is the name that has no record or doesn't have that record type, and they barf. So we have to do a lot of work to try to overcome that. Another technique is for the NSX signed zones. We actually know what exists and what does not exist. And so, for example, for the root zone, in a relatively short time, all of our resolvers know all the names that exist in the root zone. And when they get a garbage name, like the ones that Google Chrome generates to check if the ISP is lying, we can answer it instantly without talking to the root servers. So that is fine, and this is also works in a very well for us. We avoid having the resolver load the copy of the root zone because we learn it real fast from a closely located root server. And yeah, so based on experiments that have been done, this works so that we have basically 6 nines in cache-hit ratio for the root zone. One of the things we are not doing is what is called client subnet. That is one of these ugly hacks that was created at one point to try to overcome an issue that some people assume that resolution is going to take place in certain part of the network, which was something that was provided by the local network, i.e. it would not be done off network or on the host. And this leaks a lot of information. Lots of implementations are leaking bad data out, and sometimes it improves performance, sometimes it degrades performance because of it. But really bad for resolvers. It increases the memory they need to keep because answers have to be kept by netmask. But this adds lots of extra complexity, slows them down, and is bad. So we can get into philosophical arguments of how to do this or not, but we are talking to a number of responsible other authorities of how to tackle this going forward. But what I'm most excited about are these 2 extensions to the DNS protocol. Ability to talk over TLS, long-lived sessions, and the ability to do HTTPS. This allows us to totally protect the communication so it cannot be monitored or spoofed. We are seeing more and more of DNS attacks that are trying either by doing route hijacks or other things to forge answers. These 2 totally prevent that. And we have been working with Mozilla of providing an experiment of how much worse it is if everything goes over HTTPS. And basically their numbers were published not too long ago. It's a minuscule additional cost for most queries, but for the tail, for 20%, the gain is enormous. And on the data. We are very concerned about the data that is collected by the resolver. And we have a very strict data collection policy. The IP address that asks the questions is never logged from the machines at the edges. So our logging system never knows the full address. All addresses are masked. We keep the data for less than 24 hours. We run some aggregations on the data that never contain any personal identification information. The largest, most critical part we store in that, it would be what was the answer and what was the co-location that or the POP that we answered from. APNIC gets access to almost all of this data. Basically, the biggest thing they don't see is which machine in each one of our locations answered it. But other than that, they have access to most of it. And we are doing this because we think that there is way too much data out there, and people are not telling you what they're doing with it. So instead of writing a privacy policy about what we are not doing, we are actually wrote a privacy policy that says what we are doing. And if the usage changes, we will have to provide an update to our policy, and we have an auditing firm that comes in once a year and makes sure that we are following what we have published. And those audits will be made public. Martin.
So the beginning of this was to talk about the IP addresses, and there's this wonderful bootstrapping that needs to occur in the name to number process. You actually need a number to start with in order to know where to query and ask how to convert a name into a number. And so having a very well-known number, one that's easy to remember, well, we're not the first people to do this. We admit that. But with these numbers, we found that it was a nice, fresh, easy restart to tell people about these addresses. And there's something important about this. As much as easy as the numbers are to remember in the v4 world, let's admit it, these v6 addresses take a little bit more effort. There aren't easy, clean addresses that are available in the v6 world. But even so, even though we sort of went out and we talked about 1111, well, quite extensively, in fact, it's interesting, and you'll see this in the stats, what the massive difference is between the access on these numbers. So why these numbers? And quite frankly, these are numbers that don't work. These are numbers that for quite some time didn't work. And these are numbers that will continue to have issues for a long time. But if you remember right at the beginning, what I talked about was that as a company, we want to try and improve the internet. And that means going out occasionally and fixing things left, right, and center at places halfway around the world, even here. So 1111 is this IP address that 10 years ago becomes part of a pool of 1/8 in the APNIC region. But even before that, even before it was assigned or allocated, it was in print, it was in use. So here's a major hardware manufacturer, which I will try not to name, who has documentation as part of their schooling on how to build good engineers that explicitly says, just type in 1.1.1.1. And when you teach somebody to do it once, they're liable to repeat it, and at some point they're going to do it on a live network. And you know where this is going to go. On the screen also here, oh, I've got a pointer, I forgot that. Oh, no, that's not the pointer button. On that button there. So this is my local hardware store where I go and buy nuts and bolts and the occasional power tool. Well, okay, I'm a guy. Many power tools. And they have Wi-Fi there, and it has a captive portal set at 1.1.1.1. Over here, you see that this is an airline in Latin America who's fixed this problem. Their portal is no longer at 1.1.1.1. It is at 2.2.2.2. Now, we're sitting at an RIR meeting here, and we really do all understand the concept of allocations and assignments and the like. But trust me, this is only a smattering of the examples out there of people who don't understand. Here is a user on a forum who explicitly says, no, you really should use 1.1.1/24 because, well, it's available and it's easier to remember and you really should use it. And he's trying to convince other users on this forum. If I ever come across this person in real life, well, anyway. And then there's the edge. Then there is that network connection you have at home or the office that has a small, innocuous Wi-Fi router, the last device from the telco towards the end user. And sure enough, inside that device, we find hard-coded 1.1.1s repeatedly. And those units are in the millions, and they're all over the globe. This is not an issue that exists in one telco or another. We literally find them all over the world. And if you are the person involved in your CPE equipment in your telco, go off and check this. Fix it. Because again, make the internet better just by not cutting corners or making mistakes. So here's a list, a partial list, of a bunch of telcos that we worked with literally in the first couple of weeks, all of which are on that list because they fixed something. They realized that this was wrong. We found people who had test labs. By the way, remember they had the book, right? So they suddenly leaked 1.1.1.1 into their internal routing and therefore black-holed it for every one of their customers. We found it used in various different places. This is the APNIC meeting in Senegal back in June. And I met with the guy, and he fixed it, actually. And I don't have very much of a graph here because I forgot to do this graph until the next day, and we don't even really keep 24 hours worth of data. But this guy, he fixed it, and all of a sudden we saw these latent requests that already were there for DNS queries onto 1.1.1.1. And so we know that it isn't hard for people to fix this, although sometimes when it's built into CPE equipment, that becomes a little bit more scary. During those early weeks of turning this on, we did quite a lot of measurement, and we used a lot of RIPE Atlas probes. And for those people, if there are people here from RIPE, but if there are people here who use RIPE Atlas probes, you're doing a wonderful thing. It is an ability. We found so much of this information. Our team in London sat and wrote scripts and generated data and contacted telcos very much because of the RIPE Atlas data. Without the RIPE Atlas probes out there, we wouldn't have had, at least at this point, a mechanism to continue this. All right, so background noise. There's a lot of it. These are addresses that had been tested a few times, both with inside APNIC, with inside Merit, with inside Google at different points in time, and then finally when we announced them. And that history, and if you've got the slides, they'll be on the APNIC website. Go look at some of the old reports. But here's the key point. When we turned this puppy on, when we announced an address that shouldn't be used, we started seeing 10, 11, 12, 13 gigabits of traffic coming in. Nothing is listening on this IP address. Nothing at this point is responding on this IP address. This is just traffic that has been sitting dead somewhere in the world, and all of a sudden, because we announce it, we attract that data. 10, 11, 12, 13 gigabits worth of traffic is way more than there should be. If you go back and look at this a while ago, these numbers were much lower, but they were big. And I'm going to dissect some of these numbers and the like. A majority of it is on the 111 address. The 1.000 block actually has a tiny amount in comparison, but it still has traffic. What is it? Well, an awful lot of it is just HTTP traffic. Port 80, 443, the other random ports that we see in the HTTP world. We see some DNS, we see syslog traffic. Somebody somewhere has typed in 1111 into their syslog code and is merrily sending, oh, now us, clear text messages saying, I have no idea what. We don't run a syslog listener, we don't want to. This, in fact, causes us some worry, to be honest, because we don't want to see this data, but it's out there. And then there's the curious case of 1.0.0.19. TP-Link boxes seem to have that hard-coded in as their DNS resolver. That is not an address that TP-Link owns, or, by the way, just about any other ISP, and yet they're merrily sending out DNS requests. Now, I'm going to fast forward on this to tell you that after we were running for a while, we thought about this, we looked again and again, and we decided to roll up 1.0.0.19 as a DNS server and add it to the pool of the two addresses, the two IP addresses we were using. And sure enough, we know we're helping, well, actually a lot of users out there, but it would be much better if their firmware was to improve. Okay, so where's it all coming from? China, you win. You win. Hands down. We see traffic around the world, but we mainly see this traffic coming in from China. I don't know why, and I would love to have a conversation with somebody, because somebody somewhere is wasting something, CPU or whatever, sending these bits around. But it isn't, to look at it statically, the most interesting thing. Let's look at this. This is traffic that between particular hours of the day goes up, comes back down again. 5 gigs worth, 8 gigs worth of traffic. Now, these two graphs are actually from April, from when we first turned on this service. And you can see the shape is pretty dramatic. You see the IP addresses, mainly port 80 type access, etc., etc. Let's look at this. DHCP request from Macau. Somebody in Macau has something configured not quite right. This is the nature of these IP addresses. They just seem to get configured and left in there. And you know, at some point you just got to laugh, but you also got to worry about this as well. Ultimately, although we've done a lot, there's a presentation from 10 years ago when this IP address first ended up at APNIC that talks about 10 megabits worth of traffic. As I said, you know, we're seeing 13 gigs worth of traffic at this point in time, so things didn't really clean up that well. 7 to 13% of the traffic inbound to us is actually legitimate, useful traffic at this point. It's a pretty low percentage. The only good news is that we have an awful lot of dots on the map, so this isn't actually affecting us in any way. And we drop the bad traffic very, very quickly on our network. But here's a graph from this morning, just so that you know how things don't change. That traffic I showed earlier is still there. Time of day, comes on, comes off, different addresses. The traffic is for 1111 resolver is at the bottom, and the rest of it is just all noise. 1001, much cleaner. People don't seem to want to type that into equipment quite as much, or at least addresses in there. So we get a higher percentage of useful traffic. But that graph, if I break it down a little bit more and I look at the IP address on our side, somewhere somebody's got coded 1.1.7.8.9.10, and they're happily sending us a nicely load-balanced spread of traffic. Each one of those graphs is pretty close to each other. And they, as I said, they add up to an awful lot of traffic. Day in, day out, turns on, turns off. Somebody has a cron job somewhere. Turn it off. Okay, last thing I'll talk about. You want to talk about this? Talk about this. Talk about this.
Okay, I get to complain about routing. So when Marty was talking about, we use the write atlas a lot. The what is the laser pointer? Oh, the bottom one. This graph here is showing the percentage of write atlases that could reach various addresses we had. So the test address is just a normal address we have, and we were sending traffic to it as a sanitation. But it turns out it was that write atlases have a very high error rate. For various reasons. But from this graph, you should take that during the first 3 months, we managed to clean out a lot of the garbage that was happening or automatic filtering rules that had been applied in various places. But then I started thinking, where's the traffic going to? We advertise all of these addresses the same way from all our POPs. So we would assume that the traffic from a particular write atlas probe would all go to the same location. No, that is not. That is what this graph here is showing. They are going all over where they are all different, some are different, and this is not very good. And why is this? Well, some ISPs still have rules in them that treat these addresses differently. So, for example, my ISP in the DC area in the US sends all the traffic for 1001 from my house to Newark, but the one for 1111 goes to the IAD or Dulles. Both reasonable choices, but the second one was much better. I don't know why this happens. There are all kinds of others. So we did an experiment. This is hard to see on the big screen here, but we basically pinged every /24 on the network, and with source addresses being our resolver addresses, and we checked what they look like. White means we didn't get an answer. Green means all three addresses we used are the same. We have about red is when the 111 is the only one that's failing, and etc. So go look at it. But we have about 5% failure rate for quad 1, and about 1% failure rate for 10001. We want to drive this down, but why is this? Okay, Martin mentioned this before, captive portals. If you are on the hotel network here right now, you will notice that they are abusing an APNIC assigned address to Cloudflare as the captive portal. I did this test a few months ago when I was talking at MIT, and they do the same thing. The picture here looks exactly the same. I would love to have a standard letter to hand to hotels and coffee shops and others saying, you are hijacking addresses, please fix it. If you know anybody who operates captive portal networks for hotels, tell them to modify their stuff. It would also be wonderful if we could just find an address somewhere to give to captive portals to use. Adoption. Well, it has been going up. We expected that. It still keeps going up. Route leaks. Please, please stop this. I hate getting woken up at night because somebody is stealing the addresses for the resolver. It happens a lot. Why? We don't know. But route leaks are affecting all of us in one way or the other.
So this has been my subject for a while, but let's talk about this a little bit. At the moment, there's still a large amount of work that needs to be done on filtering, both at internet exchanges and on backbones. The address 1110/24 is actually an RPKI signed route. It exists in the IRR, but we still see it leaked every now and again. The only thing I can tell you, which is an interesting social experiment, of the particular leak that happened, I can't actually read that screen very well, in mid-May, late May, the leak actually happened for less than 60 seconds. One announcement, an immediate withdrawal. There's sort of a 30-second plus or minus timer on that due to BGP, and therefore, so 60 seconds. But it lasted longer on Twitter. People discussed this for days upon days upon days. But having a very popular IP address means that we end up seeing this a little bit more than we should. All right, let's talk about speed. Actually, this is your subject. You should talk about speed.
Okay. I mentioned here in the beginning that there were two things that were driving us to make our resolvers different from others. First one was the privacy. Second one was speed. Resolvers, public resolvers are really bad in marrying locations. So we decided to engineer our resolvers inside our locations to be as fast as possible, and then also try to make it as fast as possible to the outside world. So what we do to make it faster is we have pre-fetching of answers. So if we are getting something that is expiring on cache, we go fetch it out. We also have a second technique that we keep data that is supposed to be popular, hot in our caches. That is working reasonably well, but we are going to make it better going down the road because not all data is popular everywhere. For example, I am sure there are lots of people here that are reading Swedish newspapers in this location. So there is no reason to pre-fill local caches with Swedish newspapers. The other thing is when we have a resolver that discovers new information, it shares it with everyone else in the location. This is different from what most other resolvers do. They have a single cache for every metal that is running it. We share some of the data, we don't share all of the data, and this has allowed us to break certain barriers in cache data ratio. We have been running really fast. We have a number of surveys by DNSPerf and 1000 Eyes that have said that we are the best speed-wise for the public ones. But what we are most proud of is we have made it the fastest in the APNIC region. We're beating everybody there by a wide margin, except for in the Oceania, there is a local public resolver there that is doing almost as good as us, and that is great. To sum it up, to get a good market penetration for a public resolver, we needed a good addresses. APNIC had good addresses, and we were able to come to a mutual understanding of how to use them. We are supporting new technologies, and we believe that the world is going to move away from DNS over UDP over the next few years and go to more transaction or connection-oriented protocols. Because if you look at even devices like your laptop or something like that, the traffic that is coming out of your laptop is burst traffic. When you load a web page, you may generate 100 queries in 1 second, and then there are minutes until you do it again. So the overhead of setting up a connection for the burst is not that high. If we can have the connections live longer, that's even better. We also want to work on getting better connectivity to the authorities over secure channels. We have been working on cleaning up all kinds of network legacy. There's still a lot more to do. Please, like Martin asked you, go check that your network are fine, complain to your ISPs and others, and we wanted to make it fast, and I think we got there. It will get faster in various locations when we open POPs there, but yeah, thank you.
Yes, thank you very much. Now, I'm sure if there are questions, I'm going to cheat. I'm going to ask Olafur, my co-host here, a question, and then hopefully other people will ask another question. In your experience of your life at the IETF, it's true. How could you summarize the rest of the world's interest in new protocols as they have come out, or new ideas in protocols? And this is sort of a leading question, because how well do you think DNS over TLS or DNS over HTTP would really take off if it wasn't for, obviously, people's interest in privacy, but, and this is the leading part of the question, if it wasn't attached to a well-known number like we've done here? Does it change things? Can you sell technology for the sake of technology, or is it more complicated?
That is a difficult question, Martin. You can sell technology, but what we have seen in the past is there is the first mover. If the first mover succeeds, others follow. Somebody has to be willing to step forward and do things, to shake things up. And it has to have a benefit, obvious benefit that can be explained to various parties. Okay?
Hi, Anurag Bhatia, Hurricane Electric. I have two questions. One, Martin mentioned that the only way to test if 1111 works out of a network is the RIPE Atlas. I agree, RIPE Atlas is a great project, but what prevents you from sending traffic out with 1111 as source and seeing if it hitbacks any of your Anycast nodes?
That is exactly what I demonstrated in the hypercurve that we put up, that we have now built that out into our system to do the experiments like that.
So you have ways to check?
Yes, but that is not, that is also biased, that if the network is filtering the incoming packets, we will not get any answers. So
Sure.
Yeah.
The other question
to test this, we basically have to get something that we can put on the eyeball devices.
Sure. The other question I have is you mentioned eDNS, client subnet in eDNS is a privacy problem, and I have no arguments about it. It's probably true. But how would you make CDNs, large CDNs like Akamai work with 1111, where they are mapping domains to nearest user using eDNS?
We're working on it. We are talking to a number of other technology companies that have a very big interest in this, and basically what we are aiming for is to be able only do ECNS when we do it over trusted links, so DNS over TLS.
But that sounds like it won't be standard in that case if you
Sorry?
It sounds like it won't be a standard in that case if you end up in working with specific providers.
How
would a regular CDN going to work?
There is a difference between creating a standard and also testing things. Right now we are in a testing phase.
Okay.
There is a DNS privacy working group in the IETF that is just starting to work on this problem space of connectivity between resolvers and authoritative servers, and we expect this to be rolled in there.
Okay, thank you.
Hi, my name is Remco van Mook. So, Martin had an interesting question for you, and I would like to follow up on that question, and that is, if the numbers are built into software like browsers, doesn't it even matter anymore what the number is? Second, on top of that, is I very much appreciate the effort of making the internet better, and for the sake of making stuff better, you sometimes have to break things. You've gone ahead and broken everybody's hacks and optimizations on DNS in terms of trying to do clever things about figuring out where a client request comes from and so on. And do you think it's reasonable to expect for everyone to sort of reinvent themselves in terms of how you optimize the traffic coming into your network for the sake of your new thing?
Can I be mean to you?
I'm Dutch, I'm used to that sort of thing.
The answer to that one is we understand it, but on the other hand, we don't see any documentation anywhere of how people are doing it, so everybody is doing it differently.
That's the whole point.
Yeah, so there is nothing that says anybody has to do this. Mm-hmm. It's the definition for that protocol addition is experimental as a status, and if you write the code based on that RFC, you end up with an implementation that doesn't work.
All right.
And it has serious cost impact on operation of resolvers. I talked about the CAS-hit ratio, etc.
Yeah.
So this was problem moved from one space to another space, and we are in a very bad place here. We have publishers of data. Mm-hmm. We have DNS, we have the eyeballs. Those are the two that I want to talk. And then there are two providers that are not in the equation. That is the traffic provider for the authority, and then there's a possible DNS provider for the client.
Yeah. I mean, so we still haven't covered the first part of my question. I'm happy to continue talking about this one, but Martin wants to say something.
Yeah, I should talk about I should talk about the first question you had, but let me just deal with a part of the second part. 1111 also has a very strict DNSSEC model. And we absolutely know that there are zones that we will not answer because the source, the original servers are broken. And you can see that brokenness whether you use a DNS viz type public tester or use a DNS resolver that does not have strict DNSSEC on it, and therefore gives you an answer. And that's a design choice as well. And there's only one way to fix a lot of the edge case DNS, by taking a stand. And as a company, we've been willing to do that. The use of typing in 1111 or one of the other quad public DNS service or your own ISP service is still purely up to the end user to choose. And therefore, if we fail or do something that people don't like, then don't use us, use somebody else. But that immediately brings the very first part of your question up, which is, what if things get hard-coded into browsers or operating systems and or mobile devices and the like, where it doesn't matter so much about cute names or numbers and the like? It's a very valid question. But the reality is that ISPs today, if you look at every configuration, whether it be on a phone or in a broadband connection, there is a mechanism, DHCP predominantly, but others equivalent to that, that give the end user the hint of where the DNS server is. But there's been nothing that says that this is absolute and you cannot change it. We're at least giving people the option. If people hard code things into software, well, that's going to be as bad as anything hard-coded into anything. We've, as an industry, dealt with this for years and years and years. The present discussion about DNS is no different than previous discussions in days gone by on other things. The end user will vote, hopefully. The end user hopefully will become clever enough and will understand this.
I think the end user, on average, doesn't have a clue on any of this. And if their browser gives them the, hey, here's a more secure way of looking at your internet, are you cool with that? And it has a big green, yes, I'm sure, and a small red, oh no, I don't like security button. I mean, you can see where that's going.
The state of the CA world is enough to worry you. DNS is just one more thing in that area. So yes, understand completely.
Yeah.
And that's, I think, a whole separate topic of discussion, which is valid, and I'm not ignoring it. I'm just saying that's a whole different topic of discussion.
Yeah, I mean, I could stand here for another hour probably, but I do want to leave some time for somebody else. So thank you very much.
Yes, I'm Jean-Luc from MLS, New Caledonia. And as all ISP in New Caledonia, we have two links. One is local, and one is international, very more expensive one. And the traffic is normally coming from about 50% from the local link, which has all the caches, the content, I mean Netflix, YouTube, and Akamai as well, I think, not sure, and maybe other ones. And okay, on April 1st, I was very excited to assign the 1.1.1 dynamically to our customer as their DNS instead of Google. Everything worked fine. But I noticed that the traffic moved from our local link, cheap one, to the international one, very more expensive. So I had to go back to remove the 1.1.1 and put, so the question here is, did I make something wrong, or what can I do to arrange this? Or it's very...
There's nothing. No. There's nothing wrong. What you described was the state of the nation at the moment. We have 170 plus dots on the map, and more coming, more every week. That's what we do as we expand. There is no dot here in New Caledonia. So find me the right guy the right person. Sorry, to talk to, and we'll fix that.
No problem.
There you go. See, that's the answer I want to hear. And this is the same situation, whether the discussion is here or anywhere else where there isn't a dot. But the thing that's important from what you just told me is that with such a high disparity of local traffic cost to international traffic cost, it makes a difference to you even for DNS. So yeah. I'm going to go think about that one for you. But anyway, well, there's somebody else I need to talk to.
Okay, thank you.
Name and affiliation, please.
Jeff Houston, APNIC. Just to prove that I listened to you, some years ago, about 2 or 3, you did a presentation, Cloudflare, about weird DNS tricks. And the trick you had at that point was this strange way of answering NX domain on a signed domain, where you did an NSEC record that only spanned 1 byte. And the reason why was, of course, entirely logical. You didn't have to look up a database, da-da-da-da. Yeah. Cute trick at the time, and I remember that's a really cute trick. And now you're saying, and you are so right, that you're doing aggressive NSEC caching. And because of aggressive NSEC caching, you're now putting in your cache entire spans of non-existent names. And in so doing, you're actually protecting authoritative servers. Mm-hmm. Because now these random name attacks get absorbed by NSEC caching. Mm-hmm. This is really good. Have you trashed your stupid NSEC cache trick that you had a few years ago yet? And no. If you haven't, when are you going to trash it?
Nope, we have tuned it.
You've tuned it?
Yes.
Do you have details on your tuning?
Wait for the blog.
Okay.
Basically, it depends on this, whether it's domain is under attack or not.
Run out of time. So please take offline. Okay.
Thank you.
Thank you.
Yeah, thank you very much.
Thank you.
The last presenter is, thank you. The last presenter is one of the greatest researcher in worldwide. And please welcome Jeff Houston. Thank you. Do you need?
No. Maybe you can. Is there a pointer here? Hi, my name's Jeff Houston. I work with APNIC, and we certainly do a lot of measurements over the years. And this one is all about measurement, and in particular, a topic kind of close to the heart of APNIC for, gee whiz, as long as APNIC's been in existence, because IPv6 has been around for that long, which is the perennial update on where the hell are we with IPv6. To give you some background here, we stumbled across a really weird way of measuring the internet. Who hasn't seen an online ad? No one. You all see ads. Ads power most of the internet. 97% of Google's revenue is from ads. Facebook, it's ads. Why is this stuff free? Because of ads. What do ads do? They sell you to someone who wants to buy you. So ads are everywhere, ads do everything. But ads aren't quite what you think, because most ads like to sing and dance. They like to animate, they like to do things. And the way they do that is by having scripting inside the ad. So oddly enough, you can make an ad sing and dance with scripting, but you can do measurement with that exact same script. Because what you do, instead of saying, I'm going to make this thing dance on your screen, is you say, here's a URL. It's only available in v6. Can you fetch it? Here's another URL. It is available in both v4 and v6. Which protocol are you going to use to fetch it? So we run ads. We run a lot of ads. We run about 7 million ads a day. Because the thing about ads is you only pay when people click. Yeah? Our ad is really boring, and quite frankly, our bid rate is really low. Now, if I want to sell you car insurance in the United States, I have to bid $50 a click. So if you see an ad for car insurance, click on it, they're paying. This is a good thing. But if you see one of our ads, do not click. But even if you did, I'm only going to pay fractions of a cent. So it's you know, the beauty of this is then that we get, as I said, a few million folk a day. Now, the other thing about the ad system is that Google, DoubleClick in fact, try really hard not to give you the same ad twice. Now, obviously they fail, but they try hard. Now, as an advertiser, what this means is that every day, those 7 million people are new people. I don't go around measuring the same old thing every day. We actually go around measuring new folk every day across the entire internet. So this, I think, is perhaps one of the world's largest active measurement systems, if not the world's largest, because it has literally pulled in almost everybody over the years we've been running it. You may not have noticed, great. You're not intended to notice this ad. It's not intended to annoy anyone. It's just measuring. So the way we do this as well is that we work deep to get rid of caches, to get rid of all the things that make it fast in order that our servers see you. So when we give you a DNS name, a domain name, it's not cacheable, it's unique. It even has the time of day in the name. So that request to resolve that name comes back to our servers. We see you. And when you fetch the URL, we see you. So we don't need to instrument you, the ad person. We can't anyway. We can't add extra code there. We instrument our side. We make sure that every time an ad fires up, we see everything that happens. So we infer what you're capable of doing by just looking at our server. So like I said, between 7 and 10 million a day. We get new folk all the time. And we try something that's actually really quite difficult, certainly for ads. Google ads are really big in America, but they cost a lot. So because we're cheap, we don't get high presentation rates. The presentation rate in Google ads in China is a lot lower. They're there, but they're a lot lower. And so there's a certain amount of skew going on where our ad gets presented in some countries a lot more than in others. So not only do we sort of fire off the ad data and collect it back, we then try really hard to balance it so that we actually represent the fact that, whoa, about 20% of the world's internet users come from China. 15% or so, maybe a bit more, come from India, and so on. And so we try and balance the data to actually represent the balance of where real users sit on the internet so that we give you effectively a uniform view. Now, you've all heard a lot about the Internet of Things. Now, the theory is with the ad network that presenting an ad to a thing is a waste of everyone's time. We don't measure the Internet of Things because ads don't reach there. Or if they did, it was a hideous mistake. We track the eyeball internet. We track folk who see ads because the ad folk track folk who see ads. So that's something I can't correct and I can't compensate for. This is an eyeball network we're measuring. But maybe it's the eyeball network that you're experiencing that counts anyway. Things don't pay a lot for traffic. You do. You pay a huge amount for traffic. Eyeball traffic is much more valuable than thing traffic. So, a couple more things to talk about. When we introduced V6, it's not a replacement for V4. It will be a long time. Don't know when. We used to think it was going to be quite fast, but it'll be a long time before folk are brave enough to set up a consumer network that is IPv6 only. Everything is dual stack today, one way or another. Because if you can't get there in 6, you'll try 4. Sometimes it works the other way. Some systems seem to prefer 4. There are reasons behind this, and it's all about happy eyeballs. I won't go into it now. But there are 2 measurements as a result of this. When I hand you a URL that you can only get to in 6, you can only use 6 to get there. You're capable of using V6. But when I hand you a URL that does 4 or 6, I'm interested in what you choose. Because sometimes, even though you could do 6, and you know you can, you'll choose 4. Why? Let's digress for a second and talk a little bit about India. Our server for Indian users is located in Singapore. And there is a circuit across the Bay of Bengal that runs from somewhere on the Indian subcontinent, you folk will know more than me, to the Singapore island where our server is. And in V4, that's where the traffic goes. But V6 for a few of these providers does not go that way. To get to Singapore, the traffic was going from India to London, because London, and then back to Singapore. Now, if you think about it, that's an awfully long path, and the trick is it's more than 300 milliseconds. And your browser might well try to start V6, but if nothing has happened within somewhere between 50 milliseconds and 300 milliseconds, it'll just do 4. And so we saw a period in India because of difference in routing between 4 and 6, where although the capable number was right up there, the preferred was really low because the difference in V6 was so great, it was triggering the preference the other way. So that's why we measure both. Sorry about the tedious explanation, but you know, some folk are interested, I'm sure. We do long-term measurement. We've been doing this since around 2011, and this is the global picture from 2011 until today. Now, this is a classic internet up and to the right, except the last bit. Because somewhere around here, you know, 2017 was the year of V6, if there was a year. It more than doubled in 1 year, largely due to one provider in India, the Jio product, that sold millions in terms of subscriber numbers. And that just dented the world numbers. But since then, it hasn't been the same. Now, this is a live measurement system. And when our measurement platform dies, the numbers drop. Oops. So you know it's real. You know, all the warts and everything are in this data, and sometimes it's us and no one else. So when you see these kind of things, yes, we've dropped the ball. But there's something else going on. And if we sort of blow up those last few months in 2017 and 18, this is weird. Why has it stopped? What's going on? Now, sometimes it's us, but sometimes it's not. We are mystified about China. I think everyone is one way or another. We've been told recently, and no reason not to believe it, that they've done a massive rollout of V6 inside China. And so in the mobile networks, there is a lot of it. And we saw the numbers rise from very, very small up to 5% in June. This is out of focus, by the way. Who's ever controlling the focus on that overhead, you'll need to sharpen up that image. But wow, somehow it just dropped again from our measurement system. Now, we're in Singapore, not Beijing. Is this something about being not in the country and trying to get traffic sort of across the border? I don't know. We're trying very, very hard to understand what's going on. But here is a pool of 600, 700 million users who can sort of push the world's V6 dial up and down again. And none of us are quite sure at this point what's going on. But it's certainly a story that we've yet to see it. Cloudflare saw it too. This is some Cloudflare data. There's a lot of V6 traffic. There's less V6 traffic, although they restored to a slightly higher number than what we restored to. But there certainly was a burst and then it stopped. So my guess is that the ChinaNet backbone, AS4134, did something and then stopped doing something. I don't know what the something is. We'll keep on looking to see if we can find out. But whatever they did, they sort of went, whoops, too fast, too quickly, let's try something else, by the look of it. Either that or my measurement system isn't working right, we'll have to tune it up. So anyway, let's get back to the bigger story. That's the growth. Why has it stopped? Why isn't this up and to the right? Why have we slowed down in V6? What's going on? Now, one of the reasons is actually the absence of motivation. Whatever was driving you to deploy V6 isn't. What was driving you to deploy V6? What were the factors that actually made folk deploy v6. So that's the question I wanted to look at very quickly from the data we have. What's going on? Where is v6 in reality in today's networks, the first thing? Who is that economy that has almost 40% of the world's v6 users? And who is that economy? Oddly enough, India, with 242 million users because of the Geo product, is the largest pool of v6 users. The second is the USA, with Comcast, AT&T, Verizon, and a few others that have now just basically moved over. Germany with Deutsche Telekom and Brazil. So you can see the list there. Now, that's an interesting list. What's their GDP? Is this only about rich countries? Well, India isn't, but maybe there's more to it than that. Where is this? It's in strange places. It's in the West, but there it is in Brazil. There it is in India, even in Greece, but not Portugal. So there's sort of some of these funny little puzzles. And when we look at that, we're trying to make sense of what does this data mean? What are the theories about v6? Now, here is the list of ISPs with users, and it's out of focus, so let's just go off the top. Reliance, 242 million users. Comcast, 35 million. Reliance is huge, the Geo product. AT&T, Cellco, and the next is an Indian one, ICLnet, Vodafone, and then T-Mobile in the US, and then Germany. So, why isn't it still accelerating? We've exhausted the V4 pool, there's nothing left. So whatever motivated new deployments hasn't been strongly evident. What could it be? First theory, it's a toy for the rich. V6 is the last thing on the to-do list because everything else is all about getting revenue or avoiding spending money. So if you're rich, you can afford to do those projects that everyone else just can't afford to do. So in a lot of cases, it really is a case of, love to do it this year, but, you know, I've got so many other things to do, so many people, I just can't do everything. You need to be rich. So let's measure. We know GDP, we know the customer base, we can put the two together. And if I multiply the GDP per capita by the estimate of how many users each ISP has, the world's richest ISP by that metric is Comcast, because the GDP per capita in America is large, and Comcast has a lot of customers, almost 50 million. The next largest, oddly enough, is ChinaNet, not because the GDP per capita is high, it's not, but geez, they have a lot of customers. ChinaNet backbone, in our estimate, has around 280 million customers. That's a lot of people. AT&T is the next richest, and so on. Of those 20 richest, 12 of them have significant amounts of IPv6. So you'd kind of go, maybe there's some correlation there. So let's record the percentage of v6 against the value. You know, there's Comcast, there's AT&T, there's ChinaNet. Do you see a pattern there? I don't. It's not really that the richer you are, the more v6 you have. It's not an up and to the right. It's more random than that. In fact, I can go further and look at the 400 richest ISPs, and quite frankly, the amount of v6 they have is all over the place. So you don't have to be rich to do v6. You don't have to be rich. Rich ones do it, but so do less rich ones as well. 73% of users are served by ISPs outside that rich top 20. So v6 is not just a game for the wealthy. It's not just a game for the wealthy. Something else is going on. So what could it be? Maybe it's the folk that are growing, the rapidly expanding networks, the ones that really have got double the customers this year, and there aren't any more v4 addresses. You're under a lot of pressure. So let's look at the customer bases and see who's stressing out. This is the list of the 30 fastest growing ISPs across the last 16 months. Interestingly, the one that really grew amazingly quickly, 3 million customers, was a network in Thailand, advanced wireless network, that grew from 1 million to 5 million in 16 months. Wow, whatever job they did was brilliant. You know, good on them. SK Telecom in Korea evidently grew from 1.5 million to 7 million, and the list is there. Of those, who did V6? So there are 100 ISPs with more than 1 million customers that grew by more than 20%, but only 26 of them have done V6. So even the ones that are growing rapidly, and there's the growth rate here, growing rapidly, the V6 is all over the place. So it's not the case that the rapidly growing ones are doing V6. Not rapid growth. Geez. Okay, you're running out of V4 addresses. So let's calculate, because we know how big each ISP is, approximately. We understand how many customers you have, because ads will do this for us. And we know how much space you're actually routing in the routing table, so we can work out how many addresses you have per customer. Well, here's the list measured by the customer count. Now, there are a few folk on this list who totally amaze me. The folk in Nigeria, 600 customers for each V4 address. Wow! And there's two of them. There's one further up that has 350. Whatever NAT they're using is brilliant. Either that or their users are in permanent revolt. For everyone else, the numbers are much more pedestrian. 1, 2, 3 or 4 users per IPv4 address. But Nigeria kind of takes it. The other one that's big is in India, Bharti Airtel. And they have 16 estimated customers for each V4 address. So they intensively NAT. But what's their V6 deployment like? Again, if you're really running short, you should be doing 6. But the ones that are running short are not. Again, random. There's no great pattern inside those dots. It's sort of just dots. So in some ways, folk are quite happy to buy NATs. And that's not forcing them into doing 6. It's an independent decision. Even in Nigeria, which is the worst place on the world if you want to be a V4 ISP, as far as I can tell. I pity them. So again, this doesn't work. 418 ISPs have a customer population of 1 million. 81 of them aren't stressed. The rest are stressed. They have less than 1 V4 address per customer. But quite frankly, only 80 of those 337 have V6. So running out of V6 and V4 addresses won't cause you to go to 6. Running really short. 19 ISPs have more than 100 customers per address. Only one of them has a V6 deployment. Problem? What problem? NATs are great, evidently. There just doesn't seem to be a pressure to use V6 from running out of V4. You just blithely just turn on more NATs. So maybe we're looking in the wrong place. You see, IPv6 was built for a network that was architected in the 1970s, when computers used to talk to computers. Computers don't talk to computers anymore. You talk to Netflix, and Netflix downloads streaming video at you, or YouTube or something else. This is a client-server network. Clients don't need addresses, and servers don't need addresses either. Interestingly, NATs are an incredibly efficient way of addressing across a client-server network. Because in the web, I can put 1,000, 10,000 different websites on the same IP address and have security for all of them independently. I don't need all those addresses. So in some ways, the world we have, the client-server world, has an entirely different way of treating addresses that doesn't demand a unique address for everybody. So the folk who are running NAT, some of them feel the pressure, but some of them don't. Today. Now, it's always, I suppose, tempting to say, if it's going to work today, it'll work forever. No, do not believe that. V4 is incredibly finite, and NATs don't give you infinity back. They only give you 16 more bits of port space one way or another. But it does mean you can defer things a bit longer, and people are. You're still going to fall off the cliff. You know, the crunch will happen, but it won't happen today. It'll happen a bit later. So maybe the real driver in V6 is peer pressure. Let's look again at those countries where I get the 6 largest ISPs, and in most countries, only 6 are big. Most countries only have 2 or 3 mobile providers because there's only so much spectrum. And the wire providers, there aren't that many of them either. So most countries have 6 or less of large ISPs. Oddly enough, where you have V6, they group together. One party forces the rest. Geo forced India. Belgium, well, they all sat round a table because it's a small country and they just agreed. The US, T-Mobile forced them with a little bit of effort from Comcast. And the peer pressure brought AT&T, Verizon to the table. Deutsche Telekom's move in Germany has forced others along because all of a sudden it's now the norm. Same in Greece, same in Japan, same in Brazil. That sometimes it's what your competitors do that matter more than anything else. And if your competitors have taken the V6 path, you seem to be under a lot more pressure than any other metric I can think of that actually drives you towards deploying V6. So what can I say in result of this? Because time is running out and a social's coming up and I need beer as much as you do. V6 is not a toy for the rich, not anymore. It's not just something you do when you've got so much money and you can't figure out what to do on a Friday. No, it's beyond a high GDP per capita. Oddly enough, it's not for the folk who are growing fastest. It's not that. Your decision to deploy V6 is independent of your growth. It's not even the poor folk in Nigeria who are trying to cram 1,000 people to each V4 address. The gnats are still working over there, God knows how. But there's a certain amount of peer pressure. National cases help. And I think all of them together is what drives us this way. But it's a slow drive. You won't be shutting down V4 next year or the year after. You're going to be working with gnats for some time yet. Don't cancel the orders. You're going to be working with all kinds of wacko 6-4 stuff. Don't cancel the orders. You're going to be figuring out how to lie in the DNS because of your funky V4, V6 transition requires you to lie in the DNS and still use a DNSSEC provider that won't let you lie like Comcast. Good luck. I don't know how to do it either. It's a challenge. But this is the challenges we're being faced with today. So certainly it's slowed a bit, and that's disappointing. Why? No clue. No real clue, but we hope that China and you folk, all of you independently, say, well, you know, the only way we can get out of this mess is to actually do it. Because if you don't do it, we'll sit in this limbo life for as long as you want. But each year it's going to be just a little bit more uncomfortable and a little bit more expensive. Thank you.
Can we accept the question? We can accept one or two questions from audience.
Hi, Jeff Tashi from APNIC. Just to add a few things, not few things, just one thing about the motivations behind V6. Maybe for some it could be curiosity too. I was working for Bhutan Telecom before I joined APNIC. We had no reason to do V6 in terms of address exhaustion, but we still did it. And at the moment, I was just checking the stats before I walked up to the mic. AS17660 is about 18% V6 capable. So just wanted to let the audience know that sometimes it could be purely wanting to learn, wanting to do it, out of curiosity too.
You know, I suppose the key, as in many parts of the internet today, the key is always the mobile systems. Because mobility is what has the money, what drives the business. The wired internet is now just the slumland of the internet. Who cares? But mobility is a really interesting problem with this. Because for a long time, and 3G was the worst example, if you went dual stack, the cost of your gateway system's infrastructure doubled because there were 2 PPP sessions, and that doubled the rental you paid to folk like Marconi and the rest of them. With 4G, the situation changed, but interestingly, the mobile folk couldn't keep it together. So some folk like Verizon, and there are a number of others all over the planet, went native mode dual stack in 4G. So there are 2, if you will, it's all IP in 4G. There's no virtual circuits, but there were 2 connections to your phone, 1 in either protocol. But the other way of doing it was where Comcast went originally, and T-Mobile mostly, a thing called 464XLAT. And that was a brave move. The actual radio network is 6 only. There is no 4 in their network infrastructure. That's a big move. There's no path back when you do that. 4 is tunneled across the 6 network from the handset to the gateway. Now, those who have done that immediately see 80% penetration because that 464XLAT always is biased towards 6. If there's a V6 answer, I'm just there. Who supports 464XLAT? Android. Who doesn't support 464XLAT? Someone going to say iPhone? Yeah. So in some countries where iPhone penetration is big, the 464XLAT mobile product kind of goes, oh, damn, that's not going to work for everyone. Need to patch up the edges. In other places, and there are many, where Android is just the handset, it's cheaper, it's more of it, da-da-da-da-da, 464XLAT is just a lay down misere. You know, it's just so obvious. And then instantly when you do it, like in Geo, the numbers just go to the roof. So that's kind of behind the issue about, yeah, we did it. And if you choose, if you will, the right handset combination with the right technology, it just works. Thank you.
Jordi Palet. I just want to add something because probably many participants don't know. Apple has said that, at least for tethering, they are interested in adding 464XLAT, but they want the mobile operators to ask for it. So if you are a mobile operator, please ask your Apple contacts you want 464XLAT, because that will solve that problem. Thank you.
I love Apple products and I love it dearly, but gee whiz, I've got to ask them to do the right thing? Come on. Thank you. Thank you very much.
Thank you very much. Thank you, Jim. Let's close the session. Thank you for whole present there, and thank you for participant. I really appreciate your effort. Let's go to the social and let's drink the beer.
And a round of applause to Sishu as well for moderating the session. He did it very well. Thank you. Thank you. As you can see, there's various moderators in the various sessions. You know, they're all program committee members that helped put together this program. So we volunteered ourselves to do one session at least. Thank you so much. The buses will leave at 6 o'clock from the lobby level to the social event, and it's about, I was told that it's about 30 to 40-minute drive. So there's 6 buses. They will leave as they board, one after the other. And see you at the social, and have a great fun tonight. Thank you.